So, the title of my talk is Scientific Progress and Understanding, and the question I will try to answer today is the following. Is the noetic account recently proposed by Finner-Delson a more adequate realist account of scientific progress than the epistemic account? So, in order to do that, I will briefly introduce the noetic account of scientific progress, then I will try to clarify the relation between the scientific progress debate and the debate over scientific realism, then I will focus on scientific understanding, and then I will finally try to assess the noetic account of scientific progress. So, it's worth stressing that scientific progress, according to Chang, remains one of the most significant issues in the philosophy of science today. This is not only because of the intrinsic importance of the topic, but also because of the immense difficulty. The difficulty is related to the problem of how to account for scientific progress and, in the meantime, maintain a realistic stance towards science. So, philosophers of science have been concerned with the following question. What does it mean for one to make scientific progress? Usually, an episode can be said to be progressive when the state of affairs at the end of the episode is an improvement on the state of affairs at the beginning. So we need some sort of criterion in order to determine if there is an improvement. And in the debate over scientific progress, we are not interested in any kind of progress, but we are concerned with the kind of cognitive progress that consists in improving the ways in which science represents the world. Historically, there have been three approaches to scientific progress: the epistemic approach, the semantic approach, and the problem-solving approach. Just to sketch all of them. The epistemic approach, which is supported, for example, by Alexander Bird, maintains that in science, an episode in science constitutes progress precisely when there is more scientific knowledge at the end of the episode than at the beginning. So the epistemic approach takes knowledge to be the concept we need in order to understand what progress is. The semantic approach, supported for example by Popper and Niniloto, maintains that science makes progress when its theories come closer to the truth, or when its verisimilitude increases. The semantic approach so takes truth or verisimilitude to be the central concept in defining progress. Finally, the problem-solving approach, supported by Kuhn or Loden, according to the problem-solving approach, science makes progress by increasing its capacity for solving empirical and conceptual problems. The problem-solving approach holds that progress is made when a scientific development succeeds in fulfilling a certain function, namely problem-solving. So each of these accounts have received several criticisms. For example, the main difficulty for the epistemic approach is that since knowledge entails truth, the epistemic approach seems not to be able to account for cases of progress made through past false theories. The semantic approach, the main difficulty for the semantic account instead is that since it focuses on truth, it seems to allow that an accidentally true belief without any justification constitutes progress. And the main difficulty for the problem-solving account is to find a proper framework for identifying and counting problems. Indeed, if observation is theory-laden, there is no theory-neutral observational language. Accounts of progress which take for granted the preservation of some observational statements within theory chains thus run into troubles. In the last 10 years, there is a strong defense from Bird, mainly of the epistemic approach. Bird states that what is scientific progress? The answer is simple. Science makes progress precisely when it shows the accumulation of scientific knowledge. Our intuitions about whether there is progress show that progress matches changes in knowledge but not changes in truth or in problem solving. And in order to support its claim, Bird attack the semantic approach and the problem-solving approach. And his argument runs as follows with regard to the semantic approach. Imagine a scientific community that has formed its beliefs using some very weak or even irrational method M, such as astrology. But by fluke, this sequence of beliefs is a sequence of true beliefs. Then, in this community, a scientist persuades using reliable methods her colleagues that ends are reliable. In this scenario, according to the semantic account, the scientific community was making progress and then regressed after it was discovered that the method is irrational. And this is obviously an unacceptable claim, according to Bird. In order to criticize the problem-solving approach, Bird take by Loudon this example. Nicole and his contemporaries believed that hot God's blood would split diamonds. Since, according to Kuhn, a puzzle is solvable when a proposed solution is sufficiently similar to a relevant paradigmatic puzzle solution, if this solution fits such a requirement, a problem is solved, and this counts as progress. Now, suppose that someone shows to Oresman and Oresman's contemporaries that his solution cannot work. In this scenario, according to the problem-solving account, we had a solution before, now we have none, and this is regress. And obviously, also this conclusion is unacceptable, according to Bird. Now, recently, Delson has attacked Bird's approach and proposed the noetic account of scientific progress. The noetic account is an understanding-based account of scientific progress, according to which an episode in science is progressive precisely when scientists grasp how to correctly explain or predict more aspects of the world at the end of the episode than at the beginning. Being based on understanding instead of knowledge, the noetic account is supposed to be able to better account for cases in which there is progress even if there is not an increase in knowledge, and vice versa. In order to show this, Delson made some example. So he supported the claim that we can have progress and understanding without knowledge with this example. He says that consider Einstein's explanation of Brownian motion in terms of kinetic theory of heat, presented in one of his famous Annus Mirabilis papers, Investigation on the Theory of the Brownian Movement, 1905. Einstein's first paragraph reads, "It is possible that the movements to be discussed here are identical with the so-called Brownian molecular motion. However, the information available to me regarding the latter is so lacking in precision that I can form no judgment in the matter." So, according to Delson, given that knowledge is justified through belief, since Einstein's information about Brownian motion was lacking, Einstein clearly did not have the epistemic justification required to know that the movements in question were in fact real. Thus, according to the epistemic account of scientific progress, in 1905 we didn't have progress. On the contrary, according to the noetic account, in 1905 there was a significant cognitive progress in science, and so this account is superior to Bird's account. In order to support the claim that we can have progress and knowledge without understanding, Delson elaborates on a claim made by Bird himself in his paper. Imagine a team, Bird states, imagine a team of researchers engaged in the process of counting, measuring, and classifying geologically the billions of grains of sand on a beach between 2 points. Granted, this may add to scientific knowledge, but it does not add much to understanding. Correspondingly, it adds little to scientific progress. Delson adds this other example. Consider spurious statistical correlations. It happens to be true that there is a strong correlation between increases in childbirth rates outside of Berlin city hospitals and increases in stork populations around the city. When this piece of information was published in a recent satirical journal article that warned against coincidental statistical associations, there was an accumulation of knowledge that would have to count as scientific progress according to the epistemic account. However, this information provides no understanding. Intuitively, this is not a case of scientific progress. Moreover, according to Delson, the noetic account is able to accommodate some aspects of progress that the epistemic account is unable to accommodate. For example, consider the role of idealizations in scientific explanations. By definition, idealizations are not true. Nevertheless, they allow a cognitive achievement that is better understanding. The noetic account implies that scientific progress can be made by generating new idealizations. By contrast, since idealized theories are not true, the epistemic account implies that no progress is made where one generates new idealizations. Thus, the noetic account is supposed to be able to account for cases in which there is scientific progress while there is no increase in knowledge. The noetic account can also be a moderate realist account of scientific progress. We will try to assess our claims in what follows. So, let's try to clarify the relation between scientific progress and the debate over realism. The question of what constitutes scientific progress is closely related to the debate between scientific realists and anti-realists about the aim of science. Indeed, we can exemplify the aim of science, we can represent the aim of science in this way. X is the aim of science just in case science makes progress while X increases or accumulates. So, in relation with the three approaches to scientific progress we have already seen, we can say the epistemic approach entails that the aim of science is knowledge, the semantic approach entails that the aim of science is truth, the problem-solving approach entails that the aim of science is problem-solving. Von Frassen defines scientific realism and anti-realism in terms of whether science aims at its theories being true or merely empirically adequate. Since the concept of knowledge is usually construed as justified true belief, we can claim that both the epistemic and the semantic accounts are realist accounts. It is easy to see this from some quotation from two realist scholars. Here it states that virtually every characterization of scientific realism I ever seen has been framed in terms of truth. Sankey states that correspondence theories which treat truth as a relation between language and reality are the only theories of truth compatible with realism. And he adds that the traditional justified true belief account of knowledge is a minimal condition for a realist conception of knowledge. So, we can state that there is a sort of equivalence between supporting scientific realism and supporting an epistemic or semantic account of scientific progress. In both cases, we have to face the same related difficulties. That is, the difficulty of grounding the realist intuition that empirical success makes plain by making reference to true or the successful theories. And the second difficulty is that of accounting for theory change. Now, let's focus on the first difficulties. It has been called by Yuasa in a recent paper from the grounding questions. Since knowledge entails truth, accumulation of scientific knowledge requires accumulation of scientific truths. But where in science can we locate the truths that thus ground theoretical progress? Indeed, as Chang states, the difficulties of foundationalism force us to recognize that a reliable judgment of truth in the sense of correspondence to reality is beyond our reach. Therefore, even if truth should be the ultimate aim of scientific activity, cannot serve as a usable criterion for evaluating system of knowledge. If scientific progress is something we actually want to be able to assess, it cannot mean closer approach to the truth. Indeed, we have to recall that, as Stanford says, scientific realists suggest that our best current scientific theories offer us literally true, or probably true, or approximately true, or probably approximately true descriptions of how things stand in otherwise inaccessible domains of nature. As Wright has pointed out, realists take the success of our current best scientific theories as evidence that the claims those theories make about unobservable entities and processes are true or approximately true. On the contrary, the anti-realist argues that given that many past successful theories have turned out to be false, success is not a reliable indicator of truth. Successful but false theories have even enabled scientists to generate vindicated novel predictions. So there is another problem for the realists in order to claim the success entails truth. Consider our best scientific theories. Our most successful theories, quantum mechanics and relativity theory. As Barrett states, insofar as inconsistent theories cannot be true, we know that the standard collapse formulation quantum mechanics and special relativity taken together are false. Perhaps our theories, the realists could reply, perhaps our theories are approximately true in the sense that it will take only a minor change in the statement of the theories to get from our current inconsistent description of the physical world to a true description. But in case of quantum mechanics and relativity, we have no concrete idea concerning what it means to claim that we are within a minor descriptive change of the truth, since we do not know what this discrete change might be. So, thus, we cannot know whether we are now in a situation similar to that in which scientists of the past were before a revolutionary theory change. Indeed, there are many concrete backward-looking notions on scientific progress. Insofar as one can specify the content of our current physical theories, one can describe exactly how our current physical theories have succeeded where our past physical theories failed. But just as there are many backward-looking notions of scientific progress, there are potentially many forward-looking notions of progress. But here we lack any concrete grounds for comparing our current theories against the truth. Our only recourse in clarifying the claim that our best current physical theories are approximately true is to find theories that we take to be better description of the world against which we can judge the merits of our current theories. The problem is that we could that just in the future. So, the second problem is theory change for supporting realism and a realist account of scientific progress. The problem is that if we grant that science aims at truth and science makes progress, we have to maintain the idea that the progress is truth accumulation. But if progress is truth accumulation, we have the problem of accounting for past scientific theories that were empirically successful and have been rejected, that are incompatible with our current theories. The question is revolutionary changes and not merely change? Is revolutionary change in science compatible with a real account of progress? As the fact is difficult to deny that there have been revolutionary change. As Direct states, many scientific theories that were empirically successful in the past and were regarded as explanatory by past scientists have later been rejected as false. Sometimes such a rejection went together with a radical conceptual revolution which involved a change in basic ontology of the domain. So it seems that either we deny revolutions, that is, we claim that there have been only cumulative progress in science, or we deny that success and progress are related to truth. But if we deny that success and progress are related to truth, this amounts to deny realism. If, on the contrary, we try to deny revolutions, we have to account for continuity. But this seems not to be an easy task. Take, for example, Newtonian gravitation and general relativity. As Cellucci states, all the ontological presuppositions of Newton's theoretical framework are simply false. From our point of view, there is no gravitational force, no space-time background relative to which things move, no absolute simultaneity. The realist response is what can be called the selective strategy. The realist notion that only some parts or aspects of a theory can be selectively responsible for and account for its predictive success is delicate. But it is commonly accepted that the realist has to appeal to such a notion in order to square the impressive predictive success of science with various kinds of falsehoods involved in the past and present science. Which is the main problem with the selective strategy for the realist? It is, as Stanford states, that if we could have such a tool, that it's impossible to have such a tool because the appeal to selective confirmation will have to provide what we may call prospectively applicable criteria of selective confirmation. That is, criteria that could have been applied to past theories at a time and can now be applied to our own theories in advance of any future developments to say just which parts of past theories were and just which parts of present theories are genuinely confirmed by the success they enjoy. So, given this is obviously impossible. The realist lacks a criterion to reliably infer the truth from success. Consider again Newtonian gravity and the general theory of relativity. As Cellucci states, Newtonian gravity and general theory are theoretical at odds with one another. Nevertheless, Newtonian gravity can be construed as approximating general relativity theory. But it's only now from the perspective of general theory relativity that we can get a handle on the sense of approximation. According to Newtonian gravity, a body of mass m is accelerated toward a body of mass m capital due to gravitational force that is inversely proportional to the distance r squared. According to general relativity theory, by contrast, the two bodies experience no force nor acceleration, but rather follow a locally straight trajectory at geodesic in curved space-time. Despite theoretical dissimilarity in their theoretical description and fundamental ontology, MGA, general relativity theory, also share significant extra-empirical similarities. As Barrett and Malamud show that our understanding of these similarities is in large part due to the post-general theory relativity development of a geometrized version of Newtonian gravitation, GNG, which is empirical equivalent to NG, but absorbs all the information about gravitational forces into information about space-time curvature, so that gravitation is rendered a manifestation of space-time curvature. The geometrized version of Newtonian gravity furnishes us with a precise sense of the inter-theoretic correspondence between the two theories. But consider a realist at Newton's time who takes Newtonian gravity to be approximately true. Given that he cannot know whether Newtonian gravity will be retained and in any case which parts of Newtonian gravity will be considered a correct approximation, is realist claim justified? As Direct and Gisborne state, suppose that an angel appears to Newton and tells him, "Your theory of gravity is wrong. Gravity is not a force but the effect of a curvature of space-time caused by heavy bodies." Newton, being a religious man, accepts the word as true. Does he gain any understanding by doing so? This is obviously the problem of having a criteria for know which part of a theory would be retained. So Barrett states that we found ourselves in an epistemic situation similar to Newton's with respect to our current best physical theories, in that we do not yet have a perspective from which to explicate fully the senses in which they may hit and miss the mark of descriptive truth. So it seems that even if, for the sake of the argument, we concede continuity, continuity per se is not able to support a realist stance. That is, it does not establish that progress amounts to truth accumulation. Only if success is a reliable indicator of truth, an increasing success may be interpreted as an increase in truth. But since this is not the case, we can interpret an increasing success as an increase in truth. So it seems that there is a tension between the realist claims that success entails true and that our current theories are true, and historical record of past false successful theories. And also there's a tension between the realist claim that progress is truth accumulation and historical record of revolutionary theory change. In other words, neither success nor continuity seem able to ground the realist inference from success to truth. So the main divide between realists and non-realists is related to the issue of truth. Realist theories of scientific progress take truth to be an important goal of inquiry. This view is built into the classical definition of knowledge as justified true belief. If science is a knowledge-seeking activity, then it is also a truth-seeking activity. On the contrary, for anti-realists, for example, Kuhn is not skeptic about scientific progress, is a skeptic about theoretical truth. The argument for the transcendence of truth in the postscript to the second edition of Structure of Scientific Revolution, Kuhn argues that the corresponding conception of truth leads to skepticism about truth. These arguments may be summarized as follows. On the correspondence theory of truth, the truth of statement S is a matter of its matching the fact F. If the truth of S is a matter of matching F, then knowing that S is true is knowing that S and F match. Knowing that S and F match requires considering S and F independently and then realizing that they match. However, where S is scientific theory T, access to F is always mediated by theories, such as T. Since we do not have unmediated access to F, that is, we cannot consider F independent of T, we cannot know that T is true. Obviously, this is not something new, because already Kant, as Cellucci has written, deny that we can have a correspondence conception of truth. According to Cellucci, as Kant states, according to the correspondence conception, truth consists in the agreement of cognition with its object, but I can compare the object with my cognition only by cognizing it. Then, since the object is outside me, the cognition in me, all I can ever pass judgment on is whether my cognition of the object agrees, not with the object, but only with my cognition of the object. Therefore, we cannot know whether the theory about the world is true in the classical correspondence sense. This makes truth something that humans cannot reach. So, the main difference between a realist and an anti-realist account of progress consists in whether they make reference to the concept of truth. And indeed, Ninluoto says that an instrumentalist who denies the theories that truth values usually defines scientific progress by referring to other virtue theories may have. So now let's focus on scientific understanding, which is crucial in order to analyze Delsen's proposal of the noetic account. According to Delsen, the understanding-based noetic account of scientific progress is superior to the knowledge-based epistemic account, because it is possible for there to be increases in scientific understanding without accumulation of scientific knowledge, and vice versa. The definition given by Delsen of understanding is the following: an agent has scientific understanding of a given target just in case she grasps how to correctly explain and how to predict some aspect of the target in the right sort of circumstances. So, why understanding instead of knowledge? In recent years, both epistemologists and philosophers of science have been dissatisfied with the concept of knowledge and have begun to investigate the concept of understanding. There are three main reasons for searching an alternative to the concept of knowledge. The first is that the concept of knowledge does not really account for human cognitive achievements. The second reason that the concept of knowledge is not able to account for the use of false models in science. And the third is that the concept of knowledge is not able to account for past theories in a satisfying way. So let's focus on the first reason. Knowledge does not really account for human cognitive achievements. Many authors have expressed this thought. For example, Green summarized this fact saying that as externalist, especially reliabilist theories of knowledge have gained in popularity in order to face the skeptical challenge, knowledge has begun to seem much less impressive than traditionally believed. If it is true that young children and animals can add knowledge simply because they can reliably track how things stand in the environment, then it is said knowledge might be good, but it does not seem particularly valuable or laudable. As, for example, Ernest Sosa's wrote, admittedly there is a sense in which even a supermarket door knows where someone approaches. Human knowledge is in a higher plane of sophistication. Pure reliabilism is questionable as an adequate epistemology for such knowledge. Finally, Sterpetti has written that understanding as internalist condition for success, whereas knowledge does not. Even when knowledge is defined as true justified belief and justification is construed internalistically, the true condition for knowledge makes its fundamental concept of world's application cannot be demonstrated from inside. So it seems important that understanding seems to have seem to give us a reflectively accessible grounds. The guiding thought seems to be that someone who understands does not simply know that such and such is the case, but knows the why of that thing. If she understands why P, for instance, she can always say something on behalf of P or point to grounds for her understanding. So the second reason to search an alternative to the concept of knowledge is that knowledge is not able to account for the use of false models in science. For example, Catherine Elgin has written that epistemologists, speaking ex cathedra, should deny that science is knowledge. Knowledge is affective. An opinion is not knowledge if it is not true. But even the best scientific theories are not true. Although science may produce some justified or reliable true belief as byproducts, if the best contemporary science is good science, the main deliverances of good science are not knowledge. And the reason is that science uses idealizations and models that do not mirror the facts. Strictly speaking, they are false. And also the right state that science had no difficulty with using models that resist a straightforwardly realistic interpretation in order to enhance their understanding of the phenomenon. The third reason to search for an alternative to the concept of knowledge is that knowledge is not able to account for past theories. Indeed, the concept of knowledge appears to entail that past scientists who accepted theories we now have rejected as false did not possess knowledge at all. For example, Newton's theory of gravitation has been abandoned in favor of Einstein's theory of general relativity. Newton's theory is, from today's perspective, strictly false. But does this mean that Newton had no knowledge of gravitational phenomena? This seems an unacceptable claim, which derives from the fact that if knowledge requires truth, knowledge does not claim in degree. And indeed, as Rowbottom says, it would be bizarre to say that Newton's mechanics did not contribute to progress in itself because it was false. So, understanding is supposed to be, to summarize, supposed to be able to account for the human cognitive effort made in scientific enterprise, the use of idealized models in science, and the contribution to scientific progress of possible theories. But what is understanding? Understanding is usually in the literature accounted for in terms of grasping and explanation. For example, Streven says that an individual has scientific understanding of a phenomenon just in case they grasp a correct scientific explanation of that phenomenon. Beret and his collaborators say that a key feature of understanding is the fact that it involves a cognizing subject. In other words, while explanation may be viewed as a two-term relation between an explanans and an explanandum, understanding is always a three-term relation involving an explanans, an explanandum, and a subject. Another important feature of understanding is the fact that it requires coherence. For example, Wang says that understanding requires an internal grasping or appreciation of how various elements and a body of information are related to each other. Cellucci states that understanding is the recognition of the fitness of the parts to each other and to the whole. And Zakrzewski says in the same vein that understanding involves seeing the relation of part to the others and perhaps even to the relation of part to a whole. Another relevant feature is the sense of understanding. As Stroud stressed, Peirce identified the distinctive cognitive experience of explanatory understanding by isolating the moment of final acceptance. The good explanation is turned back and forth like a key in a lock. Third states that subjective sense of understanding may be conveyed by psychological impression that explanatory mechanisms are transparent and coherent, or that the explanation seems plausible and so should be confidently accepted. We say to understand a demonstration, for example, when we are able not only to follow each step of the demonstration, but also to see the idea of the demonstration, the general idea. So, grasping. But what is grasping? According to the inferential conception of grasping, a proposition is a matter of having a thought that represents the proposition and is suitably connected to other mental states through inference-like dispositions. So to sum up, we may say that understanding is a mental state that entails experiencing a sense of understanding, grasping the fit of the parts of an explanation to each other to the whole, and the ability of making inferences and connecting the understood explanation with the rest of our background knowledge. But which is the relation between understanding and truth? And this is relevant since Delsen claimed that this noetic account is a realist account of scientific progress. Let's try to see the three elements, the three features of understanding we have already seen. Experiencing a sense of understanding. According to Trout, the sense of understanding would be epistemically idle phenomenology, were it not so poisonous a combination of seduction and unreliability. It actually does harm, sometimes making us squeamish about accepting true claims that we don't personally understand, and more often operating in the opposite direction, causing us to overconfidently accept false claims because they have a kind of anecdotal or theoretical charm. So the sense of understanding is unreliable. Now let's see the second feature of understanding, that is grasping the fit of the parts of an explanation to each other to the whole. This means coherence, but as Klein and Barfeld state, coherence per se is not true conducive. The fact is that not only true sets of propositions may be coherent. For example, the proposition of a fable from a systematically coherent whole to being a fiction. The third feature of understanding is the ability of making inferences. This is the point where the two distinct interpretations of understanding confront themselves. Recall Delson's definition of understanding. An agent has scientific understanding of a given target just in case she grasps how to correctly explain or predict some aspect of the target. Now focus on how correctly predict some aspect of the target. Recall also that Delson takes the noetic account to be a realist account of progress. Since predictive success for realists is the best available indicator of truth, this means that for Delson, understanding is related to truth. Indeed, Delson himself considers understanding to be quasi-factive. Proponents of quasi-factivity claim that understanding is a subject matter by means of a theory T requires that all central propositions constituting T are true, or at least approximately so. As Delson states, understanding is quasi-factive in the sense that the explanatory, predictory, essential elements of a theory must be true in order for the theory to provide grounds for understanding. Thus conceived, the noetic account amounts to a moderately realist view of the aim of science. So, the fact is that according to the factivity or quasi-factivity view of understanding, all of the central proposition of one understanding must be true, but a few false beliefs about peripheral proposition does not undermine one understanding. This is the difference with knowledge. This allows some falsehoods to play a role while still requiring a factive component to understanding. This is a crucial issue, because if we take understanding to be factive, then we have genuine understanding only if the essential elements of our theory is true. On the contrary, if we take understanding to be non-factive, then we have genuine understanding even if our theory is not true. So, the problem, according to Elgin, is that scientists do not consider idealization an unfortunate expedient. Rather, they value it as a powerful tool. They do not expect that in the fullness of time, idealization will be eliminated from scientific theories. It is simply not the case that the bodies of information that constitute scientific understanding are, or that their ultimate successor can be expected to be composed of truths, with any residual falsehoods only occurring at the periphery. So, to conclude, let's try to assess the noetic account of scientific progress. Recall Delson's definition of understanding. And I just as scientific understanding, it should grasp how to correctly explain or predict some aspect of the target. Recall that aims of Delson understanding based on noetic account of progress, to be able to account for cases in which we have understanding in increasing understanding but not in knowledge, to be able to account for the role of false model plays in science, and to be able to account for how false theories enable understanding. Recall that Delson supports a realist account of scientific progress that he considers understanding to be quasi-factive. This understanding requires the truth of the central proposition of a theory. Recall also that understanding is considered a mental state that entails experience, a sense of understanding, grasping the fit of the part of an explanation, and the ability of making inferences. Now, if we add a more demanding feature to the previous three in order to add a realist account, that is, that understanding consists in the ability to use a theory to generate prediction of the target system, we have to say direct dilemma. As Direct says, we face the dilemma of either giving up the realist thesis that understanding requires truth, or allowing for the possibility that in many, if not all practical cases, we do not have scientific understanding. In other words, either prediction can be generated only by true theories, understanding is factive, that is related to truth, and so is not able to account for the contribution to scientific progress of models and past theories, or prediction can be generated even by false theories. Understanding is non-factive, that is not related to truth, and so it is not able to support a realist account of scientific progress. Indeed, maintaining the factivity of understanding makes understanding completely analogous or equivalent to knowledge. With regard to the theories, in fact, indeed, if understanding requires the truth of the central proposition, all past theories whose central terms do not refer have to be considered to be unable to produce understanding. Moreover, if there is a predictive success, we should have understanding. Nevertheless, we have success-independent reasons to suppose that quantum mechanics and general relativity theory cannot be both true, but they are both successful. The question is, do they both provide understanding or not according to the noetic account supported by Delson? With regard, maintaining the facility of understandings made analogous to the understanding similar or equivalent to knowledge also with regards to models. If understanding requires truth, and there are models that are evilly idealized, that is, their falsity is not simply a matter of inaccuracy, they are unable to produce understanding according to the noetic account. Moreover, if there is not understanding, according to the noetic account, there is no progress. So we could have theory change without progress. In the past, it seems that we have to claim that there was no knowledge, no understanding, no progress. Finally, The interest in understanding, as we have already seen, is partly due to the idea that cognitive human efforts should be more central to epistemology. If understanding requires through, this shifts again the focus on the external side of the inquiry, which was the focus of the knowledge-based account, which mainly were supposed to face the skeptical challenge. Conversely, if we deny the facility to understanding, understanding gives us an anti-realist account. Indeed, the claim that predictive success might not require truth is exactly what characterizes anti-realist accounts of scientific progress. As we have seen, all the three features we listed above and we've seen above can secure a realist stance on scientific progress if we try to account for scientific progress relying on understanding. If even the fourth feature, the ability to generate prediction of the target, is decoupled from true, an understanding-based account of scientific progress cannot be a realist account of progress. For example, consider a recent proposal made by Direct and Gisbert. It seems to me that this example shows us how, if we consider understanding as non-factive, we cannot but have an anti-realist account. They say that they want to replace the veridicality condition with, they propose the effectiveness condition understanding. This is the claim that understanding can only be gained from application of representational devices that are scientifically effective, where scientific effectiveness is the tendency to produce useful scientific outcomes of certain kinds. These outcomes include correct prediction, successful practical application, and fruitful ideas for further research. Where they argue that effectiveness rather than radicality is relevant to understanding. So recalling that representational radicality equals approximate truth, this means that understanding can be gained from representational devices that are false, but not just slightly false while widely so. And this is obviously very relevant for the scientific the debate over realism. Because if understanding can be achieved independently of the radicality of our representational devices, insofar as realism is understood as an axiological thesis about the desirability of having approximated true theories, the defense of the effectiveness condition against the radicality condition removes one source of that desirability. So to conclude, from what we have said, it seems far to me to conclude that Delson tries, on the one side, to relax knowledge requirements in order to widen the realist account of progress, and on the other side, to keep the truth requirement in order to maintain realism. But the two desiderata seems to be mutually inconsistent. Delson account of scientific progress is able neither to satisfyingly account for the role of models in promoting scientific understanding, nor for the role of past false theories in scientific progress. Thus, according to me, the numeric account seems not to be an adequate realist account of progress. Thank you.
Okay, well, we're all keeping to time, so we've got now a quarter of an hour for questions. So who's going to ask the first question? Oh, Michaela. I can't see the group. Okay, Michaela.
Okay.
Yes, it's rather your area, isn't it?
Yeah, exactly. It's like a soulmate. So, thank you very much, Fabio. I really enjoyed it, and I share most of exactly your concerns and worries about notional scientific progress and how to think about it. And it's something that, again, in other papers, in other works, I've been thinking about myself. The question I have is, I confess I'm not really familiar at all with Delson account of scientific progress. And I think you raise important questions there about his attempt to relax the requirement of knowledge and commitment to the requirement for realism. I have a question on understanding, because one of the points you made towards the end of your talk was that understanding implies facticity, and facticity implies truth, and if we deny the kind of facticity of understanding, we end up with anti-realist account. So I wonder to what extent we should understand understanding along the factive lines. And here I'm thinking of work of Peter Lipton on understanding, which I don't think has come up in the slides, but I've always thought that people like Peter Lipton, for example, liked very much the idea of understanding, not because it's related to truth in any way, so there's no facticity in the notion of understanding. What understanding gives you, which is different from truth, is what Peter used to call the loveliness of an explanation. So he used to make this distinction between inference to the best explanation as inference to the likeliest, more likely to be true explanation, versus inference to the best explanation as the one that provides a better understanding, the loveliest explanation. So I've always, somehow in my mind, I've always associated understanding, not with truth, but understanding has something to do with explanatory power, the loveliness of a model, of a theory. So theories can provide understanding and can increase knowledge because they are, they provide understanding not because they're more likely to be true. So in a way I was kind of surprised to see this conjunction of understanding and truth with the facticity claim, because I always thought that those were completely different things, and people could be drawn to understanding precisely because they don't want to talk about truth, but precisely because they care more about other features of the theory, the loveliness of the theory. So I think Peter, as example, he says, some of us may like a conspiracy theory, not because they're more likely to be true, but just because they're lovely. I mean, we like to think that there are all those people conspiring against us. So anyway, I wonder what you have to say.
Thank you, Michela. Indeed, in the debate on understanding, there are two positions. Those who maintain quasi-factivity or factivity and those who deny the factivity. The problem is how to combine the claim that understanding is not related to factivity or to truth, and in the meantime maintain scientific realism. Because even in the debate over inference to the best explanation or the Lipton version of this inference rule, if you adopt a realist stance, nevertheless you think that in some way or another the lovely feature of that explanation is in some sense truth. Because if you completely reject truth from your horizon, you're by definition are an anti-realist, and I completely agree with anti-realism. The problem is for the realists who want to consider and use understanding in order, as you said, to avoid complication about truth and talk about explanation, about the loveliness of theories, but in the meantime they do not want to renounce to the metaphysical claim that our theories in some sense approximate to the truth, and that truth is ultimately, as you this morning you said, for a realist, truth is correspondence. And if you try to put together this way of conceiving truth with understanding, I think that you have, as Delson I think coherently does, adopt a quasi-factive or a factive conception of understanding. Because if you decouple understanding from truth or factivity, then you do not have any way to regain truth or approximation to truth. So if you are a realist, you have a problem.
Okay. Well, this is a very complex issue, of course, and you covered a lot of ground. But there were a couple of premises that kept repeating in your talk, and both of which I find dubious. I mean, I know that they are very generally accepted. One is that models with false idealizations are thereby false themselves. I don't take that to be obvious at all, and I've myself provided arguments to the contrary. And the other premise is that truth and predictive success are closely linked. That truth somehow guarantees predictive success, and success predictively is a reliable criteria of truth. That I also find dubious. And the reason is that say combining these two denials that are in mind. First of all, models with false idealization can be true themselves. There is no problem here. And secondly, that true models do not guarantee predictive success. And the reason is that we can have a number of true models and yet fail in predicting accurately, because those true models capture just tiny bits and pieces of the world, and those bits and pieces combine themselves in a variety of ways that we don't have a model of. We have true models of those bits and pieces, such as separate causal mechanisms, but where those causal mechanisms combine in the real world and thereby generating phenomena that we would like to predict, but we fail to predict because we don't have a model of the ways in which those mechanisms combine.
Thank you. Well, obviously I focus on, as you said, in the literature, and these two claims are widely accepted when on the debate. So I think that I provide some quotation that the models with a strong, heavily idealized can be false is repeatedly accepted in the literature. But even if we think that models can have idealization, and this not means automatically means that they are false, the problem remains to me for the realist, because the problem is how to assess that these models are true. And obviously you come again to the success, because if you say that there are models which have a strong idealization, but nevertheless they are true in some sense, again we have to construct not only a conception of theory, but we should have a criterion of theory, and obviously we do not have unless we rely on success. And I came to the second point you underlined. Obviously I completely agree that true and predictive success are not reliably correlated, as many anti-realists suggested. I quoted, for example, right. But it is nevertheless the strongest argument for realists, because as already this morning Michela recalled, the last line of defense of the realists are the no miracle argument or the no miracle intuition, in which success or predictive success or novel predictive success is the best way to account for the realist intuition that the truth is the only explanation of success. So I just take the main position on the debate and try to elaborate in order to analyze just an account.
Yes, my question is to try to frame your fine distinction between knowledge and understanding. My own approach, I usually add the terminology knowledge construction, and I would like you to frame the meaning I give, the relevance I give to symmetries in this, because typically, I like very much German vibe, so look at Euclid, uses symmetries in the technical sense, and this is construction of proofs and this construction of geometric objects. And then you go to Archimedes, the fantastic remark, why is it balanced with same weights and equilibrium for symmetry reasons? It's great. And then you go to modern times, I mentioned Newton's theorem, suddenly by understanding or what? Understanding conservation principle as symmetries, as my God, really fact, it's great unity, as I said, those derivations kind of do. That what am I doing? Or even look at what Feynman did with TCP symmetry. Saccharin here, observer antimatter, framed it as the negative solution of Dirac's equation for the electron. Then Feynman says, I absolutely want to preserve the TCP symmetry, so if the charge changes, this means that time goes backwards locally. What is he doing? What are we doing in such a context? Is that knowledge construction? Is that understanding? And finally, perhaps that I proved with Mel Monteville that in all existing physical theories, symmetry breaking coexists with random event, coexists with locally reversible time, which is very important for us in biology, because for us, phylogenetic ontogenetic trajectory is a cascade of symmetry breakings. So what are we doing? Are we constructing knowledge? Are we understanding what's the role of symmetries in this case?
So, thank you. Obviously, I think if you ask my opinion, I think that we should talk about knowledge. The problem is how to conceive knowledge. The problem with analytic philosophy, they continue to understand knowledge as justified through beliefs. But I think that, as you said this morning, that truth is something we should leave to priests. And so I think that we have knowledge. And I think that science makes progress, strong progress. The problem is not try to frame all this in terms of truth. Otherwise, we have the problem and the sort of...
Maybe distinction. And what they said is that understanding or knowledge construction?
Oh, I think that we have, if we not relate knowledge to truth, I think that we can use both this concept, because I should admit that I'm sympathetic to the problem-solving approach defended, for example, today by Cellucci, but also with this kind of consideration you made. I think that understanding is clearly correlated to knowledge. I think that if we consider knowledge as advancing in problem solving, obviously in order to do this, we have to understand what we are trying to do, but in a sense that is not so strictly related to the concept of truth. This is just this. Thank you.
One last question then from David.
So I don't know the literature about doing the scientific understanding. My background, though, has been looking a little bit at the psychological work just on everyday understanding, and especially in children. And so it was very surprising to see that the claims being made about factivity, because from a sort of cognitivist point of view, that just looked, I mean, people talk about understanding as providing abilities, where the abilities include things like generating approximately correct predictions, being able to control, having generating a certain number of approximately true beliefs. But the idea that you have to have true inputs just doesn't even come up. Of course, you can use all kinds of different ways to reach that state of having those abilities. So at the risk of asking you to psychologize other people, why on earth would they have, I mean, I guess I'm just not understanding why they would have thought that it was important to have these sort of approximate truth on the input side, as opposed to, I can see maybe requiring it on the output side, right, so the output of the abilities, but it just seems odd to me, and so I was very surprised to hear it. I was wondering if you could...
I think the answer is that in this debate on scientific understanding, scientific understanding is considered to be related to understanding a scientific explanation. So if you think that you have a scientific explanation and you are a realist, obviously you have to think that that explanation conveys truth. So in this case, understanding requires truth as an input, because you are talking about scientific understanding. And they, in the literature, they consider understanding in relation to scientific explanation.
Okay.
So
very helpful.
If you want to maintain realism, you have to think that the input also is true. Otherwise, you have some trouble.
Or you can start to pull apart understanding and explanation of it. That would be another response. Okay, very helpful. Thank you.
Okay, well, thank you very much.
Thank you.